Do you guys think that a cannot be equal to 0 in this parent function for the exponential function? Why do you think a can't be 0? Rihanna? Yeah, the whole thing becomes 0 if a is 0. So we can't have a be equal to 0. Otherwise, y is just equal to 0. So that would be useless, right? It wouldn't even be an exponential function, okay? And then b cannot be equal to 1. And b needs to be bigger than 0. Underline that as well, okay? The restrictions on b are such that b cannot be equal to 1. And b needs to be bigger than 0, okay? Now, the reason that b cannot be equal to 1 is because what would happen if b was 1, guys? Brady? Yeah, it would just be 1 times 1 times 1, however many times x is, right? So what is 1 to the 5th power? 1. What is 1 to the 1,000,000th power? 1, okay? So no matter what, if b was 1, y would just be equal to a, okay? So if b was 1, y would just be equal to a for all scenarios. That's no longer exponential. You're taking the fact that this is an exponential function out of the equation, okay? All right. Now, what we are learning about these is we're going to look at them as a chart, we're going to evaluate them, and we're going to graph them, okay? Today, all we're doing is looking at them as a chart, and we're, what did I say the second one was? Evaluating. Tomorrow, we're graphing them, okay? Take a look down below. Do you guys remember when we were looking at charts, right? And I would ask you, is this linear or non-linear? Do you guys remember that? What would make a chart linear? Brady? If it had a constant rate of change, okay? So we're going to be testing now whether it's linear or exponential, okay? So check out the first one. What's the change in the x values? It's going up by 1, right? So we're going to put plus 1, plus 1, plus 1. To go from 0 to 1, you added 1. To go from 1 to 2, you added 1. And to go from 2 to 3, you added 1. What about the y values? It's going up by 2. So plus 2, plus 2, plus 2. So using our prior knowledge, we would say that this is linear, correct? And why is it linear? Yeah, it goes up by a constant rate of change, okay? So this is a linear function. And we're done, okay? So as long as your x values are increasing by the same amount, your y values are increasing by a consistent amount, you're good. Now, does the x increase need to match the y increase? No. See how it's increasing by 1 and this one's increasing by 2? They don't need to be the same. It's still linear, okay? Let's check out an exponential function, okay? Now, I want you to look at this chart and someone try to tell me what's going on here. Why would this be considered exponential? Liz? Yes, it's multiplied by 2. Very good. Okay, so linear was addition, right? Exponential, you're looking for multiplication or division. Okay, so write that down. We're looking for multiplication or division. Now, let me walk you through the entire process, right? X values are still just going to they're going to be consistently added, okay? So the x values here are going up by 1. Do you guys agree? It's plus 1, plus 1, plus 1. Now, the y values, if we were to check whether it's linear, right? We're finding what's being added. From 4 to 8, what do we add? 4, right? From 8 to 16, what do we add? 8. And from 16 to 32? 16, right? So, do you guys see how it's not linear? Because adding is not our pattern. This is not consistent, okay? But do you notice how it's going from 4 to 8 to 16? The increase is also doubling, okay? So that's how you know, all right, it's definitely not linear. So let's see if it's exponential. And then you would test, okay, I notice it's being multiplied by 2, okay? So if it's times 2, times 2, times 2, as long as it's a consistent multiplication, we would call this an exponential function.
So the top doesn't matter?
It does matter, okay? So the x values, as long as they're increasing by the same amount. Got it? Right? What's my x increase? Plus 1, plus 1, plus 1. Grace? It's being divided by 2, okay? It's being divided by 2. So remember, multiplication or division is exponential, okay? Because essentially they're the same thing. If we wanted to be picky and say, okay, we're still multiplying, what number are we actually multiplying these by? What? 1/2, okay? So it's the same as just multiplying by 1/2. You can put either one, okay? And then we would say that this is exponential.
So the x needs to just have a constant rate of
Yes, x is always going to be a constant rate of change.
But it doesn't matter if that is multiplication or
If no, it doesn't matter. It could be division or multiplication, okay? But it cannot be addition or subtraction because that would be linear.
Is there one where they're both? Like x is multiplication and division and y is multiplication and division?
Oh, yes, but that's not exponential either. Okay? Yep.
You don't have to use that. Or it's just time.
No, you don't have. What's the x value change? It's plus 4, okay? So plus 4, plus 4, plus 4. What's the y value change? Brady?
-1.
It's going down by 1. Exponential or linear? It's linear, okay? And guys, get creative, get funky, okay? Make your own. So your x's should be increasing by a constant rate of change. Make it whatever you want. Make it -6, make it 7, make it 2, make it 3. Don't be generic and do 1, okay? And then your y's, okay, make them exponential. So have them increase by something. I'm going to make my own too. But I'm going to make mine nice and fun. Has to be exponential, yes. Create your own exponential. I'm going to make one and see if you guys can figure it out. It is multiplying by 1/2, and my x's are doing what?
They're subtracting by 4.
Going down by 4. So we're going down by 4, down by 4. This is being multiplied by 1/2, -1/2 each time. Cool beans? All right. Are we good on a chart? All right, we've got one more thing for today, and then we're donezo, okay? The second thing that we're doing today is we are evaluating each function for the given value of x. Brady, what's up? Sure, okay? So all that means is, okay, this is our generic exponential function, okay? So I want you to write right above it, y equals a b to the x. A b to the x power, okay? So in this example, what is a? What lines up with a? -2. And what lines up with b? 5. Okay? So this matches our exponential function. A is -2. B is equal to 5. Okay? All we're doing is we're going to take this x equals 3, plug it in, and see what we get. So we're going to rewrite it as y equals -2 times 5. Instead of x, what do I put? 3. So it's 5 raised to the third power. Okay, now, what I want you guys to do, on the left side of your paper, you should see a common mistake, okay? I want you to draw an arrow from this point to the common mistake. I see it happen all the time. People will take this -2, and what did they do with it to get this? They multiplied it inside, right? Why can't we do that? Hold on. This is a candy problem. Why can't we do that?
Ooh.
Isabella, what do you think?
Is it because it's the base of the 5 is the base of the exponent?
You are absolutely right, but I'm looking for a more specific answer. Do you want to try again? Gio, what do you think?
Yo, Gio doesn't. Yo, Gio's nervous.
Stop.
Seth, wow.
It's because
So Brooke said it best. In PEMDAS, we start with parentheses. Inside of our parentheses, is there anything to simplify? No, it's just 5. After parentheses, what comes next? Exponents. Do we have exponents? Yes, so we have to cube this before we multiply, okay? So PEMDAS. As soon as we know that, we're going to say, okay, y is not equal to negative 10 to the third. It's equal to negative 2 times, what's 5 cubed? 125. Then we multiply it by negative 2. We get y equals? Negative 250. Okay? All right. Before we do this one, I want you to change 0.5 into a fraction. What is the same as 0.5 as a fraction? Aurora? It's 1/2. So we're going to say, all right, y equals 3 times 1/2 raised to the negative second power. All right, now I want to see who's been working hard. Who thinks they know what to do with this? Gio? Love it. You have to flip the fraction. So what am I going to get, Gio?
y equals 1 over 3 times, and then to the power of 2. No.
I'm so lost. This is what you told me to do.
No, I meant.
Okay, Gio, let's try it again. Try it again. Y equals.
So 1, and then the bar, and then 3 times 3 parentheses 1/2 to the second power.
You're kind of, I mean, you're... Aurora, what do you think? Okay, that's closer. Nick?
Y equals 3 times 2 to the second power.
There we go. Okay. Y equals 3 times 2 to the second power. Remember, a negative exponent means what? You flip it. So we're only flipping the base. What's the base of this negative 2? 1/2, right? So Gio, don't touch the 3, okay? And Val, make sure that you flip it, okay? I'm glad you guys said that because these are common mistakes, okay? So this is going to be y equals 3. What's 2 squared? So 3 times 4 is? 12. That's my answer. We're done. What? No, just done with that problem. Sorry, guys. Sorry to get your hopes up. Okay. Questions on this one? Is that a bad pen to write with? I'll switch it. Sorry. All right, C. We did it all of yesterday. Do you remember all these problems where we plugged in numbers for x? That's exactly what we're doing. Okay? So we're not like done. We're almost done. Okay? This is like, no. We have like 6 more examples. Okay? But like they'll take 2 seconds. All right. So we got y equals 2 times 9 to the negative 2. All right, guys. Our last problem involved a negative exponent. What do you think we do for this one? What do you think we do for this one? Liz?
Is it going to be 1 over 9 parentheses to the second power?
Good. So it's 2 times 1 over 9 to the second power. What's 1 over 9 squared? Nick?
1 over 81.
1 over 81. So y equals 2 times 1 over 81.
And then you get y equals 2 over 81.
Perfect. That's it. That's it. Imagine if that was the last question. Oh, wrong one. D. Y equals 2 to the times 0.9 raised to the 0. What do I get? I get 1 for this.
And so y equals 2.
Y equals 2. Okay? Now, I want you guys to remember when x equals 0, right? Remember, our standard formula is y equals ab to the x power, right? If x equals 0, do you agree that b to the x will be 1? So y is going to be equal to a, okay? Y will always be equal to that number a when x is equal to 0. Cool beans? All right, let's move on. E. Y equals 2 times 9 to the 1/2. Amina? Yes. Come on. What do you guys think? Aiden wants to say it? It's plus and minus 3. Yes. So y equals positive 6 and negative 6. Why do I have to put both? Because the square root, right, of any number is the positive and the negative solutions, okay? Because do you agree that 3 times 3 gives me 9 and negative 3 times negative 3 gives me 9? Anytime your index is an even number, like 2, 4, 6, or 8, you are going to get 2 solutions. All right? F. Stop. Y equals 1.5 times 2 to the negative second power. All right, negative exponents. What do you guys think we do? Nick, go for it. I love it. It's 1/2 to the second power. Uh-huh. Now we just multiply across. So 1.5 is over what? 1 times 1 over 4. So it's 1.5 over 4. That's it. Because 4 does not go into 1.5 evenly, okay? So we're just going to leave it like that. Wait. I'll wait. What's up? We have 2 left, guys. 2 left. G. Y equals 1.5 times 2 to the x power. Y equals 1.5 times 2 to the... It's just 1.5. Okay, last one. Y equals 1.5 times 2 to the 1/2 power. What does that mean? Square root of 2. So y equals 1.5 times the square root of 2. Do we know what the square root of 2 is? No. So we just circle. Okay, guys, I hear some of you saying it's imaginary. It is not imaginary, okay? It's a number. It's like 1.4 something. I don't know the exact number. It's 1 point something. It's not imaginary. Imaginary would be if this was negative. Then it would be an imaginary number, okay? But if it's positive, there is an answer to this, okay? But it's not what we call a perfect square, okay? Perfect squares are like 4, 9, 16, 25. They're numbers that when you take the square root of them, it's like a regular, it's an integer, right? It's not a decimal. This one, you just leave it as the square root of 2. You don't touch it, okay? Because we don't know what the square root of 2 is. We are going to be graphing these exponential functions, okay? So we already know that the function y equals a times b raised to the x power is our exponential function, okay? Now, I want you to write it over here. Y equals a, or not a, just write bx, b to the x power, okay? And we're going to talk about transformations. Do you guys remember transformations from chapter 3? When you guys hated me for about 2 weeks?
No.
Yeah? It's back. Okay. So, I want you guys to take out a highlighter and highlight this region in front of the b and after the x. Actually, leave a little bit more space, okay? So highlight these two regions, okay? All right. In these two regions, okay, if there's numbers here, those are what we call vertical changes or vertical transformations. Okay? And if you guys remember from 3.7, right? The transformations, right? We figured out whether it was vertical or horizontal based on whether it was inside or outside your parentheses, right? We treat our parentheses now as the exponent. So anything being used as an exponent, okay, in this region will now be a horizontal transformation, okay? So anything up here as the exponent will be considered a horizontal transformation. Okay? That also means, Victor. So anything in the blue region is considered a horizontal transformation. And also, guys, what do we call that blue region? Starts with an O. It's where everything you do the opposite. Opposite world, okay? So make a note of that. This region is also known as opposite world. So anything that's going on there, we're going to do the opposite. Okay, now, the beauty of these exponential functions, guys, okay, when we're graphing them, I'm going to go over a lot involving A and B, but if you ever approach a problem and you blank out on A, you blank out on B, you can always just plug in numbers and figure out what the graph is going to look like, okay? So as a last resort, you can plug in numbers and figure exactly what the graph is going to look like, okay? So what I'm talking to you about is A and B, these values of A and B that we know already before we graph it, what it's supposed to look like, okay? So with the equation y equals ax plus b, okay? These two graphs, this red and this blue one, go ahead and highlight. These are when b is a number bigger than 1, okay? These are when b is bigger than 1, okay? Now, the blue graph, right, the blue curve, is when a is positive. So this number in front, if this is a positive number, then a is going to be above the x-axis, okay? A will be above the x-axis. Okay? Now, compare that to the red curve, okay? In the red curve, A is no longer a positive number. A is a negative number. And what happened to our graph? It went below the x-axis, okay? Does anyone remember what kind of transformation is this called? When you go from the blue curve to the red curve. Yeah, it's a reflection. Very good. So, do you remember reflections, right, happen when you have what in your equation? What causes a reflection? Brady? A negative sign, right? So we just changed A from a positive value to a negative value. So it got reflected over the x-axis, okay? Is it coming back to us or no? We're still like completely lost. No? Okay. All right. It's okay if you're lost at this point. Okay, just remember, if you completely don't get the A and B part, you can still graph it by what we're going to do next, which is plug in points, okay? All right, so this next section is when B is between 0 and 1, okay? So if B is a value between 0 and 1, okay, the graph, as we move to the right, notice your graph is going to approach 0, okay? Bigger than 0, that means A is positive. Our graph is above the x-axis, okay? So this is going to be above x-axis, okay? If your graph has a negative a, guess what happens? You are below the x-axis, okay? Okay. Now, let me show, you're going to see why this is important in the next scenario, okay? In the next scenario, in the next thing that we're going to do, in the next example, you're going to see why this is super important, okay? All right, so go ahead and scroll down to the first example. Go back to the previous one, the core concept. Our graph should look something like this because B was bigger than 1 and A was bigger than 0, okay? Now, again, we're figuring out what the on the next page. So these examples are when B is bigger than 1, okay? And we're going to graph them. And then we're going to describe the domain and the range, okay? So let's start. This is our function. F of x equals 4 times 2 raised to the x power. All right, what is my A? It's 4. Very good. What's my B? 2. Okay. So now, was A bigger than 0 or smaller than 0? A is bigger than 0, so it's positive. That means that our graph should be somewhere in this region. We're not going to be down here, okay? So we already know our graph is going to be positive. Agreed? Because A is bigger than 0. Is B bigger than 1 or between 0 and 1? It's bigger than 1, okay? So we know our graph, you completely blank and you have no idea what to do, you can plug in points and you're going to see what your graph should look like, okay? So let's talk about when we plug in x is negative 2. Actually, let's start from the bottom. Let's plug in x is 2 and then we'll move our way up. So if we plug in x for 2 into this function, we're going to get f of 2 equals 4 times 2 to the second power. I just plugged in 2 for x. Do you guys remember doing this yesterday?
We never did.
Got f of x value is at an x value, right? So what do I do here to figure out f of 2? Carson?
First you do the 2 to the second power.
Good. And you get?
You get 4.
So 4 times 4 gives me 16. So that's all we need to do, guys. So we've got 16 is our f of x value. So my point is, what was my x value? What was my f of x value? 2 comma 16. Are we good with that? Did I lose anyone? Yeah. I did lose some people? Okay, so take a look. I'm going to walk you through it again. This 2 is my x value, right? All I'm doing is I'm taking this x value and I'm plugging it in for where x was in the original equation, right? So it's f of 2 equals 4 times 2, which is my b, raised to that power. So raised to the second power. Do you guys see that? Yeah. So it's 4 times 2 to the second power. I have to use my exponent before I multiply because PEMDAS, right? Exponents become before multiplication. So it has to be 4 times 4, which gives me 16. Okay? It is not 8 squared. Okay? Don't make that mistake. Carson?
I just don't understand why you write the 16 like in the f of x.
Yeah. So these are our x values. These are technically our y values, right? So then we're writing all of the y values over here.
How is that your y value?
Yeah.
Because remember, y is the same as f of x, right? Do you see what I'm saying? So we're solving for f of x by plugging in x. Okay? All right, so let's do the second one. F of 1. Pedro. What happened?
No, never mind.
Ask.
No, never mind.
You're good?
No, it's because I did it wrong.
Okay, f of 1. Aurora, what do you think?
You do 4 and then you put the 2 in parentheses and then it's to the first power.
Good.
Oh, and it equals 8.
Good. It's going to be 4 times 2, because 2 to the first is just 2, and that equals 8. So, f of x is 8 when x is equal to 1. What's my point, guys? 1 comma 8. Okay? Let's do another one. 0. F of 0 equals What do I do?
You're using another color.
Yeah, you're right. That one's bad. F of, is that better?
Yeah.
Okay. F of 0 equals, what do I do? Geo?
It's 4, then comma 2, and the exponent is 0. And it's going to be 4 times everything to the 0 power 1.
Beautiful. Okay. Very good that you said 2 to the 0 power is 1. A lot of people think 2 to the 0 power is 0. It's not. It's 1. And also a common mistake is to make that whole thing 1, right? It's not the whole thing. The only base that we make 1 is the 2. Got it? Okay. So our next point is 0, comma 4. Negative 1. So it's going to be 4 times 2 to the negative first power. Brady?
Can I go to the bathroom? And it's going to be 1 over 2 to the first power?
Yeah. So it's going to be 4 times 2 to the negative first power is just 1 over 2, right?
Did you say?
Yeah, go ahead. What is 4 times 1/2? 4 times 1/2. Nick?
It's just the 1 half.
Yeah, it's just 1/2. So it would be 4 over 2, which simplifies to 1 over 2. 1/2.
What? This implies to 2.
Isn't it 2?
I'm so sorry. It's 2. You guys are right. It's been a long day. Okay, so this point is negative 1, comma 2. Thank you guys. All right, negative 2. F of negative 2 equals 4 times 2 raised to the negative second power. So we're going to move the 2 to the negative second to the denominator, right? So this is going to be 4 over 2 squared. Agreed? What's 2 squared?
Please pardon the interruption. Would the competitive cheer team please report to the student center at this time? Competitive cheer team, please report to the student center at this time.
All right, so we have all of our points, okay? Now, we are going to plot these, and we're going to see what it looks like, okay? So negative 2, comma 1, negative 1, comma 2, 0, comma 4, and 1, comma 8. Oh, 216, it won't fit, so I'm going to imagine that it's not there. Yes, sure. Okay, and then we draw, whoops. You're going to notice that this is not a straight line. It's going to be a curve, okay? Now, make sure your curve does not go past 0, okay? Does not go past 0, right? As we make our x values high negative numbers, what is this graph approaching? What number is it approaching in terms of its y value or its f of x value? It's getting really, really close to what? As we move to the left. As we move to the left on this graph, what is it approaching? 0, right? So since it's approaching 0, okay, let's see what happens. Like, let's make x negative 16, for example, okay? So f, write this down, of negative 16, okay? Let's plug it in and see what we get. So we're going to get 4 times 2 to the negative 16. 4 times 2 to the negative 16th. So this is the same as 4 times 1 over 2 to the 16th power. So this is 4 over 2 to the 16th. Now, 2 to the 16th, I don't want you guys to calculate it, okay? But this is a very, very large number. Do you guys agree? We're multiplying 2 by itself 16 times, okay? So, since that's a huge number, this is going to be close to 0, okay? Because it's going to be super small. But this function, okay, no matter what you make x, it will never actually be 0, okay? So that helps us when we're defining our domain and our range, okay? All right, so for our domain, remember, domain involves the x values. What are the x values? Are there any x values that like the graph will not touch? Rihanna?
Oh,
Are there any x values that x won't reach? There's not. So if x, because x can be anything to the left, right? Do you guys see that? Our graph continues on forever to the left, and it continues on forever to the right. So if it goes both directions, what do we say our domain is? All real numbers. So it's going to be all real numbers. But our range is not all real numbers. Our range are the y values. And I told you that y will get really, really close, but never actually touch 0. So y needs to be bigger than 0 because our graph exists above y equals 0. So since a is negative, our graph is going to be below the x-axis. And since b is bigger than 1, it's going to be increasing to the right. Okay? And then let's plug in some values so we know what it looks like. All right? Let's start with 2. Okay? So we've got f of 2, and we just plug in. This is going to be negative 2 times 4 to the second power. 4 squared is going to give me 16 times negative 2 will give me negative 32. So this is negative 32. Let's raise x to the first power. So this is f of 1. This is going to be negative 2 times 4 to the first power. That's negative 2 times 4, which is just negative 8. F of 0 is going to be negative 2 times 4 to the 0th power, which is negative 2 times 4 to the 0 is just 1. So this is also negative 2. Negative 1, f of negative 1 is going to be negative 2, 4 to the negative first power. So that 4 is now going to get flipped to be 1/4. So this is negative 2 times 1 over 4, which is negative 2 over 4, okay? That simplifies to just give me negative 1 over 2. And the last one, f of negative 2 is negative 2 times negative 2. Whoops, that should be a 4, but raised to the negative 2 power. So 4 to the negative second power is negative 2 times 1 over 16. This is going to be negative 2 over 16, which simplifies to negative 1 over 8. And 2 comma negative 32. So I have all my points. All I need to do is plot them and see what they give me in terms of a graph. And then go down an eighth. So it's really, really close to 0, okay? Negative 2, negative 1/8. Then the next one is negative 1, negative 1/2. So between 0 and negative 1, that's about negative 1/2. The next one is at 0 comma negative 2. So 0 comma negative 2. The next one is at 1 comma negative 8. And the last one is 2 comma negative 32. Now, we can't plot that because ours only goes to negative 12. But this is enough to create a curve, okay? So your curve is going to look like this. It's going to keep getting really, really close to 0 and then explode up. Or down, excuse me. in that direction. So our domain here is what? What do you guys think our domain is? It's all real numbers, yep. All real numbers. And our range? Y is less than 0. Because our y values all exist below 0. All right, let's do one more, and then I'm going to have you guys try one on your own, okay? Graph each function, describe the domain and range. Okay, so this one, our b value is going to be between 0 and 1, okay? So, in this example, what's a here, guys? It's not nothing. Negative 1. And b is 1/2, okay? Your a is negative 1 because there's technically a 1 in front of those parentheses, okay? All right, so plug and chug, all right? We're going to plug in 2, we're going to plug in 1, we're going to plug in negative 1, we're going to plug in negative 2, and we're going to plug in 0, okay? So f of 2 equals negative 1/2 raised to the second power. 1/2 times 1/2 gives me 1/4. So this is negative 1/4. F of 1. F evaluated at 1 is going to be negative 1/2 raised to the first power, which is negative 1/2. F of 0. F of 0 is going to be negative 1/2 raised to the 0 power. Yep. Which is negative 1. F of negative 1 is negative 1/2 raised to the negative 1 power. We have to flip our fraction, so this is negative 2. F of negative 2, negative 1/2 raised to the negative 2 power. This is going to be negative 1/4, no, negative 4, so negative 4. So my points are negative 2, comma, negative 4, negative 1, comma, negative 2, 0, comma, negative 1, 1, comma, negative 1/2, and 2, comma, negative 1/4. Then all we have to do from here is plot these. All right. Negative 2, negative 4 is going to be right here. Negative 1, negative 2 is going to be right here. 0, negative 1 is going to be right here. 1, negative 1/2 will be between 0 and negative 1. And then 2, comma, negative 1/4 go up here. So our curve looks something like this. What do you think our domain is? All real numbers.
Is the domain always going to be all real numbers?
For these examples, yes, because x can be anything, right? But for examples that we're going to see in the future, it may not be all real numbers. Isabel, do you understand why it's all real numbers?
Not really.
Okay, so let's walk over it. So if you think about the x-axis as a number line, right? And your domain are all the values of x that your graph can be, right? So
Excuse the interruption. Chloe.
what we're saying for the domain is what are the values of x that our graph can be, okay? Or our graph exists at. So do you see how this is going to continue moving to the left, even though it's going to go really slow because it's going down really, really fast? But we can be anything to this side, right? And same thing for the other side, right? This is going to continue on going forever to the right as well. So whenever it's every single real number, we say all real numbers, okay? Now, y is a different story. Because do you see how if we picked 9, when will our graph ever touch this 9? Never, right? Because y values, it'll never go past 0, right? So y has to be less than 0. So our range is y needs to be smaller than 0. Does that make sense?
Yeah.
Okay. Try the next one on your own. What about the last one that we did? Okay, go back up. Our b was what? 1/2, right? What's -4 times 1/2? Or divided by 2. What's -4 divided by 2? -2. What's -2 divided by 2? -1. What's -1 divided by 2? -1/2. -1/2 divided by 2? -1/4. Okay? Same thing. So whatever your b value was, okay? This is a good way to check yourself. We should be increasing by a multiple of 4 here. And we certainly are. Okay? So whatever your b is, that should be the pattern that you notice in the exponential chart. Okay? And when we're finding the values, okay? So most of us are on the right track when we're doing, so you guys wrote f of 2 equals it's 2 times 1/4 raised to the second power. You guys with me on that? Now, remember guys, when you square something, that's saying that thing times itself, right? So this is the same as 2 times 1/4 times 1/4. Agreed? What's 1/4 times 1/4? It's 1/16, right? So this is 2 times 1/16, which is 2/16, which simplifies to what? 1/8, okay? Second one, f of 1 is 2 times 1/4 to the first power. Anything to the first power is what? Whatever it was to begin with, right? So this is going to be 2 times 1/4. What does that give me? Yeah, 2/4, which simplifies to 1/2, 1/2. F of 0 is going to be 2 times 1/4 raised to the 0 power. What's 1/4 to the 0 power? What's 1/4 to the 0 power? 1 times 2? 2. -1, f of -1 equals 2 times 1/4 to the negative first power. Now, this is where we have to be careful. Raising something to the negative power does not make it negative. It means you flip your fraction, right? You just find the reciprocal. So this is 2 times 4 to the first power. which is just 2 times 4, which is 8. Then we have f of negative 2, which is 2 times 1 over 4 raised to the negative second power. This is going to be 2 times 4 to the second power. Remember, negative exponents flip our fraction. And then 4 squared is going to give me 16, so 2 times 16, which gives me 32. Brady, what's up? Yes. All right, do you guys want the shortcut? Okay. A in this case was what? 2, right? What's B? 1/4, right? The pattern is whatever your B value is, right? That's what you're multiplying to get the next f of x value. So what's 32 times 1/4? Or 32 divided by 4? What's 8 divided by 4? What's 2 divided by 4? 1/2. What's 1/2 divided by 4? 1/8. Okay? Let's finish this one off. Let's graph it, and then we're done. Okay? So we're going to do negative 2, comma, 32, negative 1, comma, 8, 0, comma, 2, 1, comma, 1/2, and 2, 1/8. Graph them. Negative 2, 32 we can't do because we only go up to 12. Negative 1, 8, we can put it right here. 0, 2, we can put right here. 1 and 1/2, and then 2 and 1/8. Domain? All real numbers. Range? Y needs to be bigger than 0. So what we're going to do is we're going to identify the types of transformations. First off, let's identify what our parent function would be. Your parent function is going to be y equals whatever your base is. So look at your exponent, which is x minus 3. What is the base of x minus 3? 2. So it's going to be y equals 2 to the x. That's your parent function. Anything else in the equation is going to be a transformation, okay? So the first number that I see that wasn't part of our original parent function is the 4. Do you guys see that? Okay. So now, first thing you got to ask yourself, if it's not in the exponent region, if it's not up here, it's a vertical change. Okay, it's a vertical transformation. Is the 4 part of our exponent? No, so it's going to be vertical. Second thing you have to ask yourself, what operation is does the 4 have with our function? Is it being multiplied? Is it being divided? Is it being added, or is it being subtracted? Amina? Multiplied, very good. When we multiply, the transformation we should always think of is either stretch or shrink. What do you think the 4 is going to do? Stretch or shrink our graph? Amina? It's very good. It's going to stretch it. It's going to be a vertical stretch by 4. Okay? Now, why is it a stretch and not a shrink? Who remembers? Brady?
Because it is above 1.
Yeah.
When it's in between 0 when it's in between 0.1 to 1, then when it's lower than 1, then it's 2.
Exactly. Since 4 is bigger than 1, it's going to stretch our graph. Okay? If it was like 1/4, that would be a shrink, right? If it's between 0 and 1, it's going to be a shrink. Okay, moving on. Next transformation. Take a look at this minus 3. Do you guys see the minus 3? If I told you this was horizontal, why would it be horizontal? What's the difference between that red transformation and the blue one? Nick? It does have a negative sign, but that doesn't tell us that it's horizontal. Geo? Nope. Grace? It's in the exponent, okay? So do you remember how horizontal in the last time we talked about transformations was anything in those parentheses? Do you guys remember that? Or no? No? Okay, do you guys remember when we had like f of x plus 2, right? If we would look at like stuff inside the parentheses, was a horizontal change? Anything outside the parentheses was a vertical one? You guys remember that now? Think about anything in this exponent region as being horizontal. So we know it's a horizontal change. And instead of, it's a horizontal shift because we're subtracting 3, but which direction are we moving? To the right 3. Why, Aya? That wasn't you? Who said to the right? Aurora, why was it to the right 3? Opposite world, okay? Remember, if it's ever horizontal, whatever you think is going to happen, do the opposite, okay? So it's minus 3, so we would assume it would be left 3, but we're actually moving to the right 3. And the last one, the plus 2. First off, ask yourself, is it part of our exponent? No. So it's going to be a vertical transformation. Is it going to be a shift, a stretch, or a reflection? Nick? It's a shift. Not to the right, though. Up 2, okay? Because remember, anything outside is vertical, and vertical does not mean shift to the right. Vertical would mean up or down. All right, let me go back 1 second, okay? And I want you guys to highlight in this first equation the a and the plus k in red, and then this x minus h in blue. And I want you to label these red regions as vertical and the red region as horizontal, or the blue region as horizontal. Okay? Anytime you have a change in your exponent, it's going to be a horizontal transformation. Anytime you have a change outside your exponent, it's going to be a vertical transformation. Questions so far? All right, let's do like 4 more examples. All right, next one. Y equals negative 2 times 3 to the x plus 2 minus 1. All we need to do is identify the transformations. We are not going to graph this. First things first, what is my parent function? Isabella?
Y equals 3x.
Excellent. Y equals 3 to the x. Whatever your base was, just raise it to the x power. Now, anything that's not 3 and not the x is going to be a transformation. There's 4 things here. There's 4 transformations here. Can anyone name one of them? Gio? Aurora?
A vertical shrink by 2 units.
Close. Treat the negative and the 2 as separate transformations. So let's highlight the 2, right? And you said it's a vertical shrink, but this is actually a vertical what? So this is a vertical stretch by what?
2.
By 2. Now, treat the negative as a separate transformation. Who knows what this negative is doing? It's a reflection. Very good. Over what axis? It's a vertical reflection over the x-axis. All right, give me another one. There's 2 more. Grace?
So the horizontal shift to the
Very good. This green one is our only horizontal one, and it's going to be horizontal, shift, to the left, 2. It's horizontal because it's part of our exponent. It's a shift because it's adding 2, and it's to the left because we're in opposite world. And the last one. Grace.
Vertical shift down one.
Excellent. It's a vertical shift. Yep.
I wanted to ask about the horizontal with exponent. Will there be times there's maybe more than one?
More than one what?
The horizontal shift because there'll be more than one being an exponent?
No. No. Yeah, Brady. Okay. Now, even though this one's a decimal, it's probably the easiest one. First things first, what is my parent function? Pedro. Good, to the power of x, okay? This is my parent. What transformation or transformations is going on in f of x? Grace?
Vertical translation upward.
You said vertical what?
Translation upward.
Good.
Or shift upward.
It's a vertical translation or shift. And it's going up 3 units.
Does it matter if you write translation or shift?
No, either one is fine, okay? Now guys, if you are still having trouble identifying whether the translation, a stretch or a shrink, or a reflection, okay, you need to do practice. The people that are getting it have seen like so many examples that now they understand what's going on. But you will not understand it until you do the practice and you see all the different kinds of examples, okay? Let's do another one. All right. First off, what do you guys think the parent function would be for this graph? Nick? Good. Y equals 2 to the power of x. And now let's identify the transformations that are happening. Nick, can you give me one of them? Good. A vertical shift up 2. I like that one, okay? So go ahead and put, there's a vertical. Make sure your colors line up. Shift up 2. That's the red plus 2 that we have. What else is there? Gio?
There's a horizontal shift
Close. There, you're absolutely right. There's a horizontal shift of 3 units. So horizontal shift. Now remember, Gio, if it's minus 3, where is that going to move us? Horizontal. To the left 3, right? Normally. But this is actually to the right 3. Why? Val? It's in opposite world, okay? So it's a horizontal shift to the right 3 units, okay? To the right 3. And the last one. What's the last transformation? Amina? Yes, a vertical stretch by what?
By 4.
Good. Aiden, what's up? So Brady's. All right, any questions on these transformations? How do we get better at these? Practice, like a million times, okay? It's not easy, okay? You have to practice this.